Hi students, today we are going to solve the textbook numerical problems in the last chapter of physics, namely electronics and communication. So the first sum I have written on the board. The given circuit has two ideal diodes connected as shown in the figure below. So two diodes are connected as shown, they are ideal diodes. Calculate the current through the resistance R1. So you can analyze the circuit now. There is one resistance here R1 and two more resistance R2 and R3 are connected here. So their values are also given. R1 is equal to 2 ohm, R2 is equal to 3 ohm and R3 is equal to 2 ohm. Now there is a battery in the circuit which supplies a 10 volt, okay, 10 volt potential difference. Okay. Then there are two diodes, D1 and D2. So what is mentioned here? Two ideal diodes. So for ideal diodes, what do you mean by ideal diodes? The internal potential barrier across the junction is 0. So the barrier voltage V barrier is equal to 0. We have studied for silicon diode it is 0.7 volt and for germanium diode the internal potential barrier is 0.3 volt. That has to be considered as 0. Okay. Then you can see here out of the two diodes, the N region of diode D1, N region of diode D1 is connected to the positive of the battery. So here D1, the diode D1 is reverse biased, okay, reverse biased. So it does not conduct, current. Whereas diode D2 is forward biased, it will conduct, is it not? So since diode D1 is not going to conduct any current, there will be no current in this path B to E. From B to E, there is no current. So no current flows, okay, no current flow in the branch BE, in the branch BE. So when there is no current in that branch means what we can do? We can remove that part of the circuit because no current is going to flow from B to E. Therefore, I am going to remove this branch BE. Now it is opened. Did you understand why this branch BE is opened? Because there is no current. So I have removed that portion B to E. Now the circuit is simplified. Okay children, now you see the diode D2. The P region of the diode D2 is connected to the positive of the battery. So D2, the diode D2 is forward biased. Okay, it is forward biased and it conducts, hence it conducts the current. And the internal potential barrier across this junction is also considered to be 0. Therefore, now in the simplified circuit, what is the total resistance? Okay, or effective. The effective resistance in the circuit I am going to find out. So the effective resistance is now 2 ohm plus 2 ohm only. So this is 2 plus 2 is equal to 4 ohm. And what is the net potential difference? The net potential difference is equal to V is equal to 10 volt. Therefore, the current I supplied by this battery, therefore, I is equal to V by R effective. So, this is equal to 10 volt divided by 4, 10 by 4. So, this is equal to 5 by 2 is equal to 2.5. Okay. Now, you can see that the current sent by the positive terminal of this battery flows from the point A to B, then B to C, C to D, then back to D to F. So it is a closed circuit. Same current only is going to flow through both the resistances. Understand? Therefore, the current supplied I, the current supplied by the battery or the current flowing through the resistance R1, both are one and the same. So we can write like this. Hence, the current, what is asked here? The current through the resistance. So the current through the resistance R1 through R1 is I is equal to 2.5 ampere. So this is the answer. Have you all understood? So in this type of problems, if number of diodes are given in the circuit, means you have to first analyze the circuit and find out which are the diodes forward biased and the other diodes which are reverse biased. Eliminate the diodes which are reverse biased, then make the simplified form of the circuit. You can find out the current. Okay, I hope you must have understood well. Fine.